Hey everybody, Mr. Regan here, and up to now we've been doing a lot to examine some of the claims that our ground team has for why our space pod is moving away from the space station. And those claims are important in understanding that different forces can cause different types of changes in velocity. Whether it's the first claim, talking about how the thruster force caused the space pod to move away from the space station, or the second claim talking about how the thrusters only slowed the pod and it ended up crashing and bouncing off the station. Both claims give a reason for why our pod is moving away from the station, even though different forces were used to cause the same velocity change. Now, we're going to take these claims a step further, and we're going to look to model how those claims have caused the same type of velocity changes for our pod. So in this guide video, we're going to be taking the modeling tool that we used in previous activities and look to show what those claims are saying. To do that, I'm going to be showing you how to use the features in the modeling tool to show a cause and effect relationship. Cause being the different forces we saw with the thrusters, and the effect being how it caused the pod to move away with a different velocity. I'm also going to be showing you how to model both claims in the before, during, and after boxes. So I'm going to be showing you how to make inferences about the different information in each box and how to add certain things into certain boxes to show each claim. So if you look at the next set of tasks, task 5 and task 6, you'll notice that they look almost identical. In the first one, you're going to be modeling the first claim, how the force of the thrusters changed the velocity of the pod. In the second one, you're going to be modeling claim 2, how the force of the thrusters caused the pod to slam or bounce off the station. Each one has the same set of directions. You're going to be adding the modeling tool to your drive. You're going to be dragging and dropping some of the features we'll go over into the model, and you'll be pasting a screenshot below. So let's take a look at the first one. In the first claim, we know that the thrusters cause the pod to move in the opposite direction, and this is different from what should have happened in the normal docking sequence. So in the first row, you'll notice we have our normal docking sequence. Our pod approached with a medium velocity, a medium force of the thrusters was applied to the left, and then the space pod was able to stop and dock. I know it stopped because there's no velocity tails here, but that didn't happen. And this is where claim 1 model, this next row, comes in. Your job is going to be to model the thrusters causing the pod to move in the opposite direction. So we have our pod approaching with that medium velocity, and you're going to need to decide what size force do I need and what direction of that force would cause the pod to move in the opposite direction, or the thrusters to cause the pod to move in the opposite direction. So do I think I need a small force going right? Do I think I need a medium force going left? Or do I think I need some sort of large force in one of the directions? You'll have to decide. In the after force section, this is where you're going to show the velocity of the pod after the thrusters are used. So would the pod have a small velocity going right? Would it have a medium velocity going left? Or would it have some sort of large velocity in one of the similar directions? You will only need to add a force arrow and a velocity tail to those two boxes and those two boxes only. Once you've done that, you'll screenshot it for task 5. In task 6, you're now going to be modeling claim 2. Claim 2 says the thrusters only slowed the pod, it didn't stop. The pod hit the station, which made it bounce and move in the opposite direction. So you're not going to be modeling the pod hitting the station. You're going to be modeling what happened right before it hit the station. So modeling what the thrusters did to the pod before it bounced off the station. So for example, again, we have our normal docking sequence up here. Here you're going to be modeling what happened before it bounced off the station, because we know it bouncing off the station caused it to go in the opposite direction. So for example, we have our medium velocity going right, as we've had in the before, and you'll have to decide which force arrow would cause the pod to keep going, leading to it hitting the station. Would I need a small force going right to cause it to keep going and hitting the station? Would I need a medium force going left to cause it to slow down and end up hitting the station, or a large force in some direction? Where would the velocity tail go? Do I need a small velocity tail going right to show it later colliding with the station? Do I need a medium velocity tail going left to show it again colliding with the station, or a large velocity tail in some direction? Just like the first model, you're only going to add one force arrow here in the middle one and one velocity tail here in the after force box. So take a second. Do you feel like you understand how to use the features in the tool to show that cause and effect relationship? Do you feel like you understand how to use the arrows and the velocity tails to show the cause, the different thruster forces, and the effects, whether it moved in the opposite direction or whether it continued on to bounce off the station? Do you understand how to model both claims in the before, during, and after? Do you feel confident you understand what the starting velocity was before the force, what the forces were in that middle section, and what the velocities of our pods were after the force of the thrusters were used? If the answer is yes to both, put your X in green. If one or more of those are confusing, put it in yellow or red. If you have questions, reach out. And as always, good luck.